Well, welcome, kiddies. Today I'm going to talk to you about something we call long division. Well, back in my day, before they had the calculator, back when your grandmother was a boy, well, let me show you something about long division. Well, first of all, you're taking a couple of numbers up here, and then you just put it in a little bar. Oh boy. And you put the number you're dividing underneath. Oh boy, the joints don't work like they used to. And you set it up like that. Well, now we have a long division problem. And all you do is see how many times 23 goes into 5. Well, not very many, so I have to go to the next number. 23 goes into 54 2 times. 2. And then I multiply. 2 times 23 is, carry the 2, divide by pi. It's 46. Then all I do is subtract that dandy number. And then I take 54 minus 46, I get 8. Alright, now I need to bring down this 3. Throw it down there. Now we've got 23 goes into 83. And let's see, that goes in 1, 2, 3 times. And let's see, 3 times 3 is 9. 3 times 2 is 6. And I subtract. Well, let's see, 13 minus 9. Oh, that would be, let's carry the 2. That's going to be 4. Borrow, and it's going to be 7. And it's going to be minus 1. That's a 14. Okay. Now I'm going to bring down 6 all the way down here. Alright, 23 goes into 146. Let's see here now. It'll be 1 time, 2 times, 3 times, 4 times, 5 times, 6 times. Oh boy. 6 times 3 is 18. 6 times 2 is 12. And now we got ourselves a dandy. 16 minus 8 is, see, that's 8. We need to borrow there, and so now we have 3 minus 2 is 1. We got 18. Alright, let's bring down this 3. And how many times does 23 go into 183? Let's see, that's a 1, 2, 3, 4, 5, 6 to get us to there. And let's see, 7. Let's try 7. 7 times 3 is 21. 7 times 2 is 14. Plus 2, 16. Alright, I'm going to subtract here. 3 minus 1 is 2. And 8 minus 6 is 2. And we're just 1 shy. Oh boy. Well, now 23 is not going to go into 22. So what we need to do now is, let's see here. We need to write the remainder. So let's put the remainder over here. 22. Well, my teacher wouldn't have that. I got to put that in a fraction. Put it in a fraction of what's left. So let me write the final answer right over here. We got 2367. And then I need to write this remainder as a fraction of the divisor. Well, let's do that. Let's say 22 on top. 23 on the bottom. And that is how we used to do it.
logging onto the website and checking out our Fusion page. Tonight I'm coming to you live from, well, it won't be live for you, but I'm here in my house on a nice Saturday evening. You can see what I do for fun. I'm doing some math here, and I'm glad you could join me. Just like Grandpa was doing, we're going to actually do a little bit of long division, but we're using polynomials. Obviously, you wouldn't be able to do this on your calculator, so let's just give it a shot. I'm going to show you the rules after this, so just try to pay attention and see if you can figure out what's going on. If you can't, make sure you write down those rules, and then you'll figure it out for sure. So first of all, just like long division, I'm thinking of these like numbers, okay? And you want to think of how does x plus 1 fit into x squared? And the answer is it doesn't, okay? So we got to look at this whole thing here, so you got to move on. So it's not going to fit in here. We're going to take x plus 1, which is a binomial, by the way, into this trinomial. So we're going to take this, and we're going to have to put in this whole thing. Well, how many times does x go into x squared? Or what can we multiply x by to look like x squared? Maybe a better way to think of it. And the correct answer is x. Okay? Now, if you can take x times x, you get x squared. Okay? Now, x times 1 is just x. There it is like that. So x squared plus x. Now, just like Grandpa was doing with the long division, once you write the number under here, you need to subtract it from what's given. So I'm going to put it in parentheses, and I'll put a little subtract sign. Now, if you remember from a couple days ago, we learned about smotoing. So you're going to go ahead and smotto this, and watch how easy this becomes. I don't like parentheses, so I'm going to change this to adding, and I'm going to change the signs of everybody inside. Okay, this was positive, this is positive, they're both negative now. Now it's just an adding problem. Take care of it. X squared and a negative x squared cancel each other out, which is what we wanted. Okay, if they didn't, you need to go back and pick a new number to try out. So now 4x and a negative x, let's see, 4, this is negative 1x, so 4 minus 1, another way to look at that, and that's a total of 3x. Okay? Once you pick 3x, just like Grandpa did, you bring the next number down. So you have plus 4. And now we have to think of how can we make this first number, this first x, look like 3x? And the correct answer would be to multiply it by 3. So we're going to positive 3, so we're going to put 3 up here. Take 3, multiply it by x plus 1. 3 times x is 3x. 3 times 1 is 3. Again, put the bar under there, put it in parentheses, quick subtract sign out there, and now we're going to use our smotto trick. Alright, 3x and a negative 3x, let's see, they're going to cancel each other out, they're gone, you could put 0 if you want to, but I wouldn't bother. 4 minus 3, this gives us 1. Now, Grandpa, he was telling us about the remainder. He put it up here, he would have put R1. Okay? R1 is okay, but we're a little more sophisticated than that now. So we're going to make sure that we put the answer, x plus 3, and then we're going to write this as a fraction. So just put plus 1 over, don't forget what you divided with, the dividend, or excuse me, divisor, x plus 1. And that's the final answer. Nothing left to do. But you're usually going to end up with 2 binomials, and occasionally you'll get a remainder. Sometimes this will come out to 0, and that's a good thing, but this is the end of this problem.